Today's lesson is a little bit longer, so feel free to pause, stop, rewind whenever you need to. We will be talking about angles, their measures, and properties. So first things first, start a table, a chart like this one in your notebook. So on the left side, you will have definitions, postulates, theorems written down. On the right side, you will have a diagram. I will be going over very quickly over definitions, but as I said, feel free to pause the video, write down the definition, and then look at the diagram or listen to my explanation first and then pause and then copy it down. All right, without further ado, let's go ahead and get started. Our first definition is going to be definition of an angle. We already know what the rays are, and an angle is the union of two rays that have the same endpoint. So I will have the same endpoint, and then my two rays are going to go in whatever direction. So I have ray AB, and I have ray AC. The common endpoint is point A, and now I'm going to call my angle BAC. The vertex always has to be the middle, or I can call it angle CAB. It doesn't matter which letter I will start, which ray I will start with, but the vertex has to always be the middle letter, so BAC or CAB. I can also call it angle A if there are no other rays sticking out of there, so it's very clear, and we usually label it with a little arc. In some notations, you will see a little arc with a tick mark there. I'm not going to be using a tick mark. I'm just going to use a little arc or two arcs if it's a different angle. Now, the sides of the angle, those are the two rays that form it. So the sides are going to be AB and AC. Those are the sides of the angle. And the vertex of the angle is the common endpoint of the two rays. So point A is the vertex of the angle. I already mentioned that. Now, the measure of an angle is how much it opens, so the amount of openness of the interior of an angle. And the unit of the measure is degree. When I say, when I specifically mean the measure of an angle instead of an angle, I'm using measure of angle ABC. Measure of angle ABC. If I say angle ABC, I mean the diagram. So angle AB. C, that is going to be angle ABC. If I mean that measure of angle ABC equals, I don't know, 50 degrees, then I'm going to say measure of angle ABC equals 50 and then a little symbol for degrees. There are other ways to measure the angles, but for now in geometry we're only using degrees. So it is important to remember to label degrees, even though it might be annoying at points sometimes, but we are going to label it. Next, the measure of an angle. Oh, I already mentioned that. Okay, skipping this guy. Angle measure postulate. First part is a unique measure assumption, and that is the assumption that says every angle has a unique measure from 0 to 180. So in geometry, we're using this assumption. So if you have an angle, it can be a very skinny angle. Our angle can have two rays that are pointing the same way. I will talk about it in a bit. So this angle is going to be 0 degrees. I can have another angle. We'll talk about the name for this angle. Or I might have an angle where my two rays are pointing the opposite ways, and then I will have 180 degrees. But everything else, if I have now the second part pointing down here, then now my angle is, this one is still an obtuse angle, right? It cannot go more than 180 degrees. In geometry, that is our assumption. Unique angle assumption says that if you have any ray VA, starting with V and then going through point A, and I have any real number R, so let's say I have angle R, number R is given, I don't know, 39.53. Between 0 and 180. There is a unique angle BVA in each half plane on VA such that measure of BVA equals R. So that means that I can draw my angle BVA going like this. And this angle is going to be 39.53 degrees. Or, because VA splits my plane into two halves, right? This is upper half and this is the lower half. Upper half and the lower half. So it says there is a unique angle in each half plane. So in this lower half plane, I will have another angle that I can graph over here. I use the similar color. So I might have angle BVA going like this. And this angle is also going to be 39.53 degrees. So unique angle in each half of the plane. But in total, there will be two because there are two halves. Part C. Zero angle assumption. That's what I mentioned before. If you have VA and VB that are the same ray, so VA, and then I have the second ray VB going the same way, yeah, then this angle over there, it's zero degrees, right? They're pointing the same way. There is no openness there. However, if my angles VA and VB are opposite rays, so my angle, I'm going to start with VB so that I stay consistent with the colors, and then VA goes this way, VA, then this angle is going to be equal 180 degrees. Measure angle BVA is 180 degrees. Opposite rays. Next part of angle measure property says if I have VC, ray VC in the interior of angle AVB, then measure angle AVC plus CVB is AVB. And this one is a very important one. It's called angle addition property. We'll be using it quite often. So let me draw a diagram for you. We have angle AVB, and then I have VC somewhere in the interior of AVB. Very often students think it goes like through the middle. It doesn't have to. It can be anywhere in the middle, in the interior of angle AVB. Interior means the angle that is less than 180 degrees, right? It's not on this side. So VC. So then what I can say is that measure angle AVC, so this angle over here, plus measure of angle CVB, the angle over here, is going to be equal the measure of the whole thing, right? Which kind of, it makes total sense. So a lot of geometry theorems, postulates, they make total sense. So you add two smaller angles, you get a bigger angle. This is called angle addition property. Next, we have a definition of an angle bisector. That's another one that we will be using very often. We have angle PVQ, PVQ, and we would say that VR, ray VR, is an angle bisector or bisector of an angle PVQ, or sometimes we say angle bisector. If it is in the interior of PVQ and measure of angle PVR over here, sorry, that's supposed to be R, PVR is equal to RVQ. So if those two angles are equal, then I would say that VR is an angle bisector. Okay, so that is the definition of the angle bisector. That is another very important one to remember later on when we will be talking about proofs. You will have to remember all those definitions and postulates. So start memorizing them now. But again, as I said, they make total sense. Few definitions about special angles that you probably know from the middle school. Zero angle. So if M is the measure of an angle, then the angle is zero if and only if measure of angle M is 0 degrees. It is an acute angle if your measure of the angle is between 0 and 90. It is a right angle if the measure of the angle is precisely 90 degrees. Your angle is called obtuse if the measure of the angle over here is between 90 and 180. And finally, we have a straight angle if the measure of this angle is 180 degrees. 90 degrees. So those definitions you probably know from middle school, as I mentioned. Next definition is something new, something that you probably don't know, and another very important one to remember. Now we have two angles. The measures are M1 and M2. So then we would say that the angles are complementary if and only if your measures of angles are going to add up to 90 degrees. So I have measure of angle M1 and M2. If I add them up, I'm going to get 90 degrees. Do they have to look like this? Do they have to share a side? No, they don't have to. That's why I drew a diagram that looks like this. If I add them up, right, I will get 90. I can have one angle pointing this way, another angle pointing that way, but if I, or pointing up, like so, but if I add this angle, let me actually erase this one. Yeah, but if I add those two angles, I am going to get 90 degrees. So they will be complementary angles. They complement each other. They're like, hey, you look so pretty. And the other one is like, oh my gosh, thank you. You look so pretty too. They complement each other. Okay, not complement. The one that I just say would have an I in here. Supplementary angles, if and only if the sum of the measures equals 180. So the easiest way to draw them is like this. So this is measure of angle 1, and this is measure 1 and measure 2. They add up to 180. But same thing as with the complementary, I can draw one angle going like this, another angle going like this. If I add them up and the sum equals 180, sum of the measures, then they're called supplementary angles. Next definition is adjacent angles. So we have non-straight, non-zero angles. They are adjacent if and only if. You can abbreviate it to IFF, remember that notation. A common side is interior to the angle formed by the non-common sides. So in this case, when we're talking about adjacent angles, now we have to have the common side. This is the common side of my two adjacent angles. So this angle and this angle, angle 1 and angle 2 are adjacent angles. Angle 1 and angle 2 are adjacent angles because the common side is in the interior of these two sides that are non-common sides. And that brings us to another definition. Two adjacent angles form a linear pair if and only if their non-common sides are opposite rays. So here the non-common sides, they formed whatever, some angle. Now the non-common sides, they are opposite rays, like so. Okay, pretend it's a straight angle. And then the common side, well, let's say it goes this way. So now I have these two angles, this one and this one, angle 1 and angle 2, and they form a linear pair. Now think about this for a moment. If those angles, angle 1 and angle 2, they form a linear pair, what do you think we can say about them using the definitions that we just had? How would they be called? Now, if you have your solution, your answer, your guess, you can write it down, or you can just get a verification confirmation that you got it right. So if those two angles form a linear pair, then they will be supplementary. That is called linear pair theorem. Most of you probably guessed it right. And that's exactly what I was just saying before, that most of these theorems are very, very common sense. So if two angles form a linear pair, then they are supplementary, right? So if I have my angle 1 and angle 2 form a linear pair, then measure of angle 1 plus measure of angle 2 has to be equal 180 degrees. Linear pair theorem is what it's called. It's not a definition, it's a theorem because it gives you a result. It doesn't explain what it is, right? It tells you that, oh, they are linear pairs, so that they are supplementary. Now back to the definitions. If we have two non-straight angles, then they will be called vertical angles if and only if the union of their sides is two lines. So I have this angle and this angle. Those are vertical angles, angle 1 and angle 2. Do you see any other vertical angles here? Think about it. Pause the video if necessary. There are two other vertical angles. It's angle 3 and angle 4. So vertical, it doesn't mean that they're located vertically from each other, right? They can be located horizontally or at an angle like I have here. But the union of their sides is two lines. The sides of angle 1 are this one and this one. Those are the sides. The sides of angle 2 are those two sides. So if I now highlight them, right, those two sides, and then let's say I have those two sides, now you can see that, oh, this part is a line and then this part is a line. So those two angles 1 and 2 and 3 and 4, they are called vertical angles. And there is a theorem that comes with it, which I should have asked you to guess, but I forgot. So if two angles are vertical angles, then they have equal measures. You can see it from the diagram. You can see that measure of angle 1 has to be equal measure of angle 2, and then measure of angle 3 is equal measure of angle 4. So right now we're not proving any theorems, so you'll have to trust me on this one. You should be able to see it kind of like on the diagram and see that, oh yeah, that sounds true, that sounds right. But this is a vertical angles theorem. Theorem means that it's a statement that needs some proof. As I said, we're not proving it right now. You'll have to trust me on this one. We might be proving it later.